A. So you should understand the term called as isotherm, and the other one is isobar. I hope you may be able to understand from the title of these two words. Iso means same. Therm refers to temperature. Similarly here, isobar, that is at the same pressure. So what happens to adsorption? That is, adsorption increases or decreases with respect to pressure at constant temperature. We talk about the isotherm. Temperature remains constant. We are trying to find out the behavior of adsorption with respect to increasing pressure. That is isotherm. The next one we have to talk about isobars. What are isobars? Isobars, the pressure is maintained constant. Now we have to talk about the behaviors of adsorption, increases or decreases with respect to the temperature. So here we are going to discuss the two different conditions. One is what happens to the process of physical adsorption and what happens to chemical adsorption, and then isobars. That means on the x-axis I am going to have x by m. That is, x refers to the amount of adsorbate, and this m refers to the amount of adsorbent. Let me repeat it again. X refers to amount of adsorbate. That means, let me clarify again. Adsorbate is the material which goes and get fixed over the surface. For example, we saw the ink and the chalkpiece. So ink is adsorbate and chalkpiece is an adsorbent. So x by m is taken in the y-axis. And in x-axis, we are going to discuss, since it is an isobar, pressure is maintained constant, only what is going to change? Temperature is going to increase. For example here, 1, 2, 3, 4, just for example I am giving. So the temperature increases from left to right, that is in the x-axis. And here, for example, let us have that x value, number of gas molecules fixing onto the surface of the metal seems to be 100, and the m, the surface of the solid, remains same, that is going to be 10. The value here comes out to be 10. So at a very low temperature, for example, if the temperature is equal to T, value is 1 degree, just for example I am giving you, here maximum adsorption takes place. At a lower temperature, maximum adsorption takes place, the value is 10. These are all example values only. Maybe we will take a temperature is equal to 2 degree, I am increasing the temperature, then what happens? The amount of adsorbate fixing onto the surface will slowly decrease. That means it will go away from the surface of the metal. Then it becomes a 90 by 10. The value becomes 9. It decreases. Again I am increasing the temperature. Next time 80 by 10 decreases. This behavior will continue. Then what happens? You will get a graph where the values of temperature, whenever you are increasing the temperature, then the adsorption will slowly decrease. This behavior we can see in physical adsorption. Let me repeat it. In physical adsorption, when we go for an isobar, that is, pressure is maintained constant, and the number of gas molecules coming and fixing over the surface of the a solid surface we are considering. In that case, whenever you are maintaining the pressure constant and trying to increase the temperature, from a lower temperature we are increasing, the amount of adsorption, that is the X by M value, will slowly get reduced and finally will get a very low value. That is, adsorption will decrease with the increase in temperature. This is for physical adsorption. Let us consider the same for chemical adsorption. Chemical adsorption, same way, in the y-axis we are going to have the X by M ratio, X by M, and in the x-axis we are going to have a temperature on the increasing trend. So what happens in this graph, you can see, slowly the value will increase and reach a maximum and then it will start decreasing. So what do we understand by this graph? Whenever you are increasing the temperature, the amount of gas molecules or the solid gets attached to the material, the solid material increases because it requires certain amount of energy for the activation of the surface area. So after the activation of the surface area is done, the maximum adsorption X by M value will get the maximum level. Then there is a process of desorption takes place. What do I mean by this word desorption? That means decrease in adsorption will take place. That means the adsorbed molecules will slowly go away from the metal surface. So we have to understand this process of adsorption, particularly for chemical adsorption. At the beginning, with increase in temperature, adsorption increases and it reaches a value and then it slowly gets a decrease. So this is with respect to isobars. Next we have to learn about isotherms. So in isotherms, temperature is going to be maintained constant. Maintain the temperature constant and try to go for the identification of adsorption, how it behaves. So we are going with the FREUNDLICH adsorption isotherm. So this is an interesting thing. FREUNDLICH adsorption isotherm. So FREUNDLICH adsorption isotherm we are going to discuss here. So what is this idea? When we consider a gaseous molecule is giving a formula X by M, that is gas molecules going and fixing over the solid surface. In that case, X by M value is giving an expression K into P to the power 1 by M. Whereas boys, the X refers to the amount of adsorbate and M refers to amount of adsorbent. And this K and N are a constant. This N is also a constant, but the N's value should be always less than unity. That is the condition he is representing. P refers to the pressure. So you wanted to link what is the relationship between pressure and adsorption when temperature is maintained constant. Temperature is maintained constant. That's why it is called as isotherm. And they are discussing about the pressure and influence of pressure over the behavior of adsorption. So in case if it is a solution, then he is changing the expression this way. X by M is equal to K into C to the power 1 by M. Here he is talking about pressure. Since it is a solution, here he is talking about the concentration. So let us take only this, that is on the gaseous molecules. Gaseous adsorbate fixing onto the surface of the solid adsorbent. Then take log on both sides. So log X by M will be equal to log K plus 1 by N. This goes in front. 1 by N into log of P. So this is the latest expression. So what is he going to do with this? He is going to have both the things linked in the form of a graphical representation. So that is called as Freundlich adsorption isotherm. How is going to link on the x-axis? He is going to take x by m. In the y-axis, he is going to take x by m, and in the x-axis he is going to take the pressure, increasing trend in the pressure. At beginning, when the pressure is low, the adsorption is very low, and when pressure increases, the adsorption increases. After some time, it maintained the constant. So this is the first type of graph he received when he was having an adsorption of the gaseous molecule over the solid surface on the y-axis and pressure on the x-axis, and he observed this kind of graph. It clearly indicates that the x by m is directly proportional to pressure. When the pressure increases, the adsorption also increases. Now in the next case, he is comparing log x by m with respect to increasing pressure, that is log P pressure. There he received a straight line with a slope value of 1 by n. So this indicates if he is extrapolating, he will get a log k value here. So this is a clear indication for us to understand the pressure is playing a role in the adsorption. Limitations of this Freundlich adsorption isotherm. This first limitation is this Freundlich adsorption isotherm is purely empirical, and it is valid only for a particular range of pressure. Afterwards it was not showing a good results. The next one is the K and the N values, they seems to be constant according to Freundlich. K and the N values seems to change with the varying temperature. So these are the main limitations of Freundlich adsorption isotherm. So dear students, you have learned a lot about adsorption. Now it is our time to discuss why to learn a lot about adsorption, what are the applications and which are the areas we are talking about adsorption. The presently we are using masks to protect ourselves from this fast spreading this coronavirus, and similarly in the World War I, Americans and British soldiers used the same methodology of adsorption. So where could they use it and what are the advantages? During the First World War time, there was so much of poisonous gases and smoke around the place. The soldiers were not able to breathe properly. But during the time, they were supplied with masks with activated charcoal. But activated charcoal has a capacity to absorb the poisonous gases and dust particles and smoke particles from the atmosphere, so that the breathing of the soldiers were very normal. So this was one of the advantages, and they used this activated charcoal adsorption methodology. The second one is if you want to form the high vacuum pumps, highly perfect vacuum pumps, that means that there shouldn't be any of the air molecules present inside. Even traces of air molecules present, like helium, can be removed by the adsorption technology. And in case some of the gadgets or some of the experiments, for example, with the preparation of carbon dioxide in pure form, the moisture's presence is a big trouble. So it has to be removed, the water molecules has to be removed. For the purpose, you can go for alumina or silica gel. Similarly, in blast furnace also, purified oxygen has to be supplied. In that case also, you can use a silica gel to remove the water molecules for the plant. And the third advantage of learning about application of learning about adsorption is converting hot water into drinkable water. That means hot water may carry metal ions like Ca2 plus or Mg2 plus. So they make the water hot. It is not palatable, we can't drink them. So how to remove this metal ions like calcium and magnesium? They used permutates, that means the resins which can extract or remove this calcium and magnesium. For example, their formula may be Na2, Al2, Si4 and O12. So the resins are filled with these materials. When you pass a hot water which is carrying calcium ions or magnesium ions, Mg2 plus ions, they go in the place of two of the sodium ions. Because sodium, they are univalent, unipositive ions. So they will be removed, calcium may get attached, so you get Ca, Al2, Si4 and O12. So two NaCl molecules in there. For example, if we go for calcium chloride addition into this permutates. Next, what happens once this calcium and magnesium is removed, our water becomes soft water. We can use it for all the purposes of drinking and washing the cloth, everything. But what happened to the permutates is they got stuck with the calcium ions. If you want to regenerate them, that means calcium has to be removed and the sodium has to be added. So the same process in a reverse direction you can try it off. You just add a salt solution into the permutator. The calcium ions will be replaced with the sodium ions. Then the permutates can be regenerated. So this is one of the method. Next method is ion exchange method. The fourth method is ion exchange method. So they use the ion exchange resins for the purpose of removing the cations and anions. So what are ion exchange resins? For example, alkyl sulfonic acid resin is available. That resin can easily give out H plus ion. Imagine they have two of the alkyl sulfonic acid resins. And suppose a salt carrying a calcium ion or magnesium ion, a solution comes. This resin has the ability to capture this cation. So the cation exchange process is going on. In the place of two of the H plus ions, one of the calcium ion will get accumulated. So you get RSO3 twice calcium or magnesium will get attached here. So that you will release two of the H plus ions. So this is cation capturing process. Similarly, anions can also be done by this method. So tetraalkyl ammonium hydroxides are taken. Here hydroxide is an anion. Tetraalkyl groups are added. When you are treating with maybe chloride ion or sulfate ion, SO4 minus. So in the place of this OH minus ion, that Cl minus or SO4 minus will get attached. Thereby, anion can be removed. The troublemaking anion can be removed. The next application of adsorption is purification or refining of petroleum and vegetable oils. The fuller's earth or silica gel can be used to purify the petroleum or vegetable oils. And we are using the white colored sugar. So the sugar in the sugar can be removed by passing the sugar solution into activated charcoal. That is, activated charcoal animal charcoal will remove the color out of the sugar. So decolorization of sugar is possible with this adsorption phenomenon. You can also try it at home. You in your aquaguard water filter, if you open there, you can able to see the activated charcoal carbon filter. So that filter will remove all the colors and odor out of the water which is coming for our drinking purpose. Dear students, the next application of adsorption is chromatography. So what is chromatography? The color-oriented identification or estimation of an organic compound is possible. So that technique we call them as chromatography. Chrome refers to color. And there will be a fixed layer that is adsorbent. Mostly it is a silica gel or alumina can be taken. Over that, an adsorbate will go on the fix. So there we talk more about adsorption phenomena. Chromatography, the stationary phase and a mobile phase, moving phase. Both of them will work with the phenomenon of adsorption. Use of application of adsorption is in the field of catalysis. That means what are catalysts, how are they useful for us. Elaborate discussion about catalysts we will be learning in the second part of this lesson. And particularly if you want what is meant by a catalyst, we can convert vegetable oil into vanaspati. Okay, so the vanaspati making process involves presence of nickel at 473 Kelvin. So how about this oil can be converted into vanaspati? If you want like a dalda kind of thing, that is, the nickel molecule will have onto the surface large number of hydrogen bubbles. So these bubbles will go and get hydrogenated, the oil get hydrogenated and get converted into a thicker material called as vanaspati. So this process is called as a catalyst or catalysis. In this area also, adsorption is very useful. Dear students, the next application of adsorption is about how adsorption is useful in qualitative analysis. For example, the blue litmus solution, when you are adding to Al3 plus ions, changes into red coloration. This red colored thing, when you are adding ammonium hydroxide, it forms the blue lake. The reason is the hydroxide ions join with this Al3 plus ion to form aluminium hydroxide. Here it shows the solution is acidic in nature. On adding ammonium hydroxide, there is a blue lake formed. This is purely the concept of adsorption. The next application of our adsorption lies in the field of pharmaceutical industries. That is, they are very useful in the field of drug application. Drug application means taking medicines when we are ill. So those medicines, they go and get adsorbed over the molecules of receptors and the problem of the illness are getting cured. The next advantage of adsorption is how are they useful in mordants and dyes. For our textile are colored because the mordants or the material will make the dye material to go and fix onto the surface of the fabric. So there also we learn about adsorption. And the next one is when we talk about concentration of the words. Yes, concentration of the words means when sulfide or particularly example, they are very light in nature. When we use fine oil, the fine oil will attract the sulfide ore, the sulfide will go and fix over the surface of the oil, and thereby the concentration of sulfide ore is possible. And finally, the adsorption indicators, and particularly in precipitation titrations, when we are adding an indicator, the indicator goes and get fixed over the surface of the precipitate and indicate the end point of the reaction, the completion of the reaction. So dear students, till now we were talking about the first part of our lesson, surface chemistry, that is mainly about adsorption and types of adsorption, what is adsorbate, adsorbent, what are the different factors influencing, and FREUNDLICH isotherm and ISOBARS, and we learned something about what are the applications of adsorption.